from the ocean meet a mountain range. A moving inland from the oceans contains large amount of water vapor. California has more cooler temps and ocean water since some of the water from the North Pacific. Most of the hot air comes from South America. That's why the South is always hotter.
But the unequal heating of Earth, and that means when the Earth passes through the atmosphere. All right, now since Mark took forever, I'm gonna keep it short and simple. The sun's energy passes through the atmosphere and it heats the surface. But the problem is the surface does not warm up evenly, and there's three primary causes to this. The first one is at which the angle hits the surface, so it either hits perpendicular and oblique, and that affects the heating. The other cause is the amount of surface area. So if there's a smaller surface area, it heats up higher and it heats up at a higher latitude. Therefore, the higher latitude is always going to be hotter in mid-latitude and the polar regions. And of course, some areas are darker than others, and that also affects the heating. For example, if it's black or dark, it absorbs more than it would be white or light colors. And well, yeah, that's why it heats up.
Currents are global patterns of air movement that are imitated by the unequal heating of Earth. As a result, the air begins to rise. When the air rises, it begins to experience low atmospheric pressures and adiabatic cooling. The cooling causes the air to reach a Saturn point. This leads condensation, which causes cloud and precipitation. Condensation also causes latent heat release, which offsets some of the adiabatic cooling and becomes a strong driving force to make the air expand further and rise more rapidly through the troposphere. The top of the troposphere is chilled by adiabatic cooling. It's hot and dry as a result. Regions at 39 north and south are typically hot, dry deserts. The area of Earth that receives the most intense sunlight, where the ascending branches of the two Hadley cells converge, is called intertropical convergence zone. As a result, the tropics experience seasonal patterns of precipitation similar to the heating cells are the polar cells. The convection current are formed by air that rise at the polar cells. The convection current are formed by the air that rises 60 north-south and sinks at the poles. At the poles, the air moves back towards 60 north and south, completing the cycle. The pattern of the air circulation is largely responsible for the locations of rainforests, deserts, and grasslands on Earth. Earth's rotation has an important influence on climate, particularly on the desert's directions and prevailing winds. The faster rotation speeds closer to the equator causes deflection of objects that are moving directly north and south. The deflection object's path due to Earth's rotation is called the Coriolis. The prevailing wind systems of the world are produced by a combination of atmospheric convections. Currents are the Coriolis effect, whereas the south of the equator produces prevailing winds that come from southeast. The Coriolis effect also explains that prevailing wind direction in the mid-latitude. If the Earth were not rotating, the air would move straight north in the north hemisphere and straight south in the northern hemisphere. In the southern hemisphere, the prevailing winds are from the northeast. From the northwest. In both cases, these winds are called westerlies. Finally, the Coriolis effect helps understand the prevailing wind direction in the polar regions. Because of this, polar winds come out of the northeast in the northeast hemisphere and cut out the southeast in the southern hemisphere. These winds are called easterly. Simply stated, the atmospheric convection currents of the tropical and polar latitudes. The mixing of currents in the wind latitudes and the Coriolis effect cause the prevailing wind patterns that occur worldwide, although local features such as mountain ranges can alter wind direction significantly. Savage.
Weather happens on the time schedule from seconds to days. Climate, on the other hand, is on the average where weather that occurs in a given region over a long period, typically over several decades. It's not possible to predict weather more than a few days into the future, but we can make general observations about global, regional, and even local climate. So typically, like as Arizona, the closer to the equator, typically receives tremendous amounts of precipitation, makes it hotter and makes it dry. Regional differences in temperature and precipitation collectively help determine which organisms can survive in each region. The layers closest to the Earth is the troposphere. It is the densest layer of the atmosphere. Most of the atmosphere is nitrogen, oxygen, and water vapors occur in this layer. Above the troposphere is the stratosphere, which is much denser, which helps for UV rays coming from the sun not to cause damage and cause cancer to the organisms.
Examined for the influence Earth's weather and climate unequal heating of Earth, atmosphere convection, currents, the location of Earth, and the... Dude, I don't know what the hell it is here, dude. Mira.
Ni nadie le entiende.
Coriolis?
Así dice.
Coriolis? Y luego aquí, ¿qué dice? A ver, relation or...
Rotation. Rotation.
Oh, like you just...
A ver. ¿Dónde se quedó?
Hey, your earphone, this one.
Voy a grabar. Tidal axis.
For Northern. $10 million.
Oh, no, that's $10 million.
I didn't have it.